Yeah, I'm Morris Jackson. I build custom models of stamp mills and mining equipment. I have been restoring mines and gold panning for about 25 years in the Phoenix, Arizona area. I built this stamp mill, 5-stamp mill. It's a replica of the typical 5-stamp mill back in 1800s and early 1900s. This is what they call a 5-stamp mill. Each stamp weighs about 1,000 pounds, and the rotation of the cams is 60 RPMs. And so that means with a cam, the shaft goes up and down, the stamp goes up and down 120 times a minute. So it's 5,000 pounds that goes up and down 120 times every minute. Okay, that goes transferred into the stamps, and that crushes the ore. The ore is, this is flooded with water, and it keeps crushing until the ore is small enough to go through the screen, which can be adjusted to whatever size they want to come out according to what ore they're using. And then it goes on to a table here. In the old days, the table was copper coated with mercury. Since you can't do that anymore, the modern ones that run these mills use carpet with the screen on top of it. The gold's heavy, so it settles on the carpet, and then the screen lets the trash run off it into a collector. This part of the video shows the front of the stamp mill. This shows a side view. This is the drive train that drives the bowl, what we call a bowl wheel, and this can run idle, or you can engage it with this idler wheel. So that's how they shut the mills down. So, okay, this is the back, what I call the back of the stamp mill. Here you can see the cams. They're two-sided cams. There's the bearings on the camshaft. This is a feeder that feeds the ore into the mortar box where the stamps are located, and this is the feeder table here. These are removable. This is the drive mechanism for the stamp mill. It's a 120-volt motor, and it drives this jack shaft with a pulley that reduces the speed, and it feeds out in here to another pulley which reduces the speed further until the camshaft is turning approximately 50 to 60 RPM. Now we're going to run the stamp mill. Turn the switch on. That starts the jack shaft running, and then we pull the liner in, and that actually operates the stamp mill. Okay, here's a front view of the stamp mill operating. Motor's running. I'm going to engage the stamp. So you can see the stamps. The water flows in through here, the ore feeds into the back, and it keeps crushing until the ore goes out through the screen, as I said before. Also notice when the stamps are going up down, they're also turning, so that the ore in the box keeps moving around so it doesn't pile up in one place. So this is basically the operation of the 5-stamp mill. Okay, I'm going to now explain some of the parts I made. This is a table here with, I use a cloth on here, and this screen is like a gutter screen. These stamps are CO2 cartridges. These upright stamp shafts are arrow shafts, like archery, and these cams are made out of, these tappets are made out of spools, and the cams are made out of plexiglass, so I'll show it better on the other side. These are jacks, and what this does is when the stamp mill is running, this goes under and this holds the jacks up, so when you start it, the stamps won't run. Okay, that's enough on this side. Okay, everything on this stamp mill is pretty well custom made. I bought very little material that's already made. You get a better view of the cams here. Those are cut and made out of plexiglass and glued together with a super glue, and you can see the cams a little bit, or the tappets a little bit better. These are the bearings. This is plexiglass housing with a 1/4-inch bore bearing inside a roller bearing. There's 2 roller bearings in there, and there's 2 roller bearings in the jack shaft. Everything here has roller bearings on it. This is what they call the feeder. The ore goes in here. There's a table that turns and feeds it in this slot here. This has to be crushed down to 2 inches to be able to get through this slot here. It goes in the mill and gets crushed. This is a feeder table, and this shows the working. What I've done here is the Electricity comes in here, goes through a switch, goes into this box, back termination box in the rear, goes from there into the motor. So if there's anything goes wrong, we just disconnect here and replace the motor, whatever we're going to do. So everything here is pretty much custom made by